be here on Friday for my test because you have to go to that meeting, so we can go ahead and work something out for you. Okay, so Kaylee, I'm just hot. You're gonna have to turn it on low cool and turn it closer to the blue because I'm hot. Okay, what does the word product mean in the bell ringer? Okay, so if product means multiplication, then we actually need to multiply 4x minus 3 times 2x plus 1, which means Sam was actually a genius because we do need to FOIL this. That's perfect. It'll take it a second. It's slow. Okay, so first is the first two terms. We multiply them and we get 4x times 2x. What do we get? 8x squared. Outer is really the 2 outside, so 4x times 1, so we get just 4x. So I'm doing FOIL. I did first, I did outer, and now I'm going to do inner and then last. For inner, I'm going to do negative 3 times 2x, and I get negative 6x. And then last, I do negative 3 times 1, and I get negative 3. Okay, but that's not my final answer because there are some like terms that can combine. So what is my final answer? Thank you, dear. Okay, the reason Ayana knew that is because 4x and minus 6x can go together. 4 minus 6 is negative 2. So that's how we got to 8x squared minus 2x minus 3. Are there any questions on this bell ringer? Now what's going to happen on a standardized test is it's going to be a little more complicated than that. They'll probably have a picture like a rectangle. And they'll put 4x minus 3 on one side and 2x plus 1 on the other. And they'll ask you to calculate the area of the rectangle. It's still going to be the same steps because area for the rectangle is base times height. So it's still going to be the exact same steps we followed. But Harrison has to think a little harder because he has to remember the formula for area of a rectangle. It's less spelled out for him. Okay, are there any questions on that one? Okay, on our second bell ringer question, it's got 2 parts, and I know front groups likes factoring, so I'm sure they've already done it. I need to know 2 things that add to give me that middle term, which is a negative 6. 2 things that multiply to give me the last term, which is an 8. Okay, what multiplies to 8? 4 and what? 4 and 2. Okay, 4 times 2 is 8, but 4 plus 2 is not negative 6. So what am I going to do about that? Okay, negative who? Negative both. Negative 4 plus negative 2 is negative 6. Negative times a negative is a positive. Perfect. So since my factor is negative 4, my factor is x minus 4. Since I picked negative 2, my other factor is x minus 2. Are there any questions about that one? Can someone go ahead and tell me the answer to the next one? Okay, she needed to know 2 things that added to give her a 2 because that was the middle. 2 things that multiplied to give her the last, which was a negative 48. She's right. 8 times 6 is 48. 8 minus 6 is positive 2. Since we chose a negative 6, that's why it's x minus 6. Since we chose a positive 8, that's why it's x plus 8. Perfect. Okay, are there any questions about the bell ringers?
Teachers, just a reminder, if you don't mind, go ahead and post your attendance at this time, please. Thank you.
Okay, go ahead and get out your notes. I'm going to be colorful today. Like, I'm going to use a highlighter in addition to my mini colors anyway if we're going to have our colors. We have briefly hit on the reason we can fly through Chapter 9 is we briefly hit on all these things anyway, previously. We're just going to go more in depth in this chapter than we have in the past. Pierre, why your mark is absent? Yeah. Was your engineering thing today?
No, I came here in time.
Okay, I know you came here in time. I'll email and ask about it. Okay. Okay, so we're going to talk about reflections. Where do you see a reflection? Where do you see a reflection? Where do you see a reflection? In the mirror. Where else can you see a reflection? Yeah. Anything in water. Thank you for playing along with me with my game. Okay, what do you think it's called? It says a reflection is a flip of figure in a line called the, what do you think that line is called? It's called line, and then of. Any guesses on that? Yeah, Junior, that's the third word. Line of reflection. It's a real original name. They spent a lot of time thinking of that one. Okay, all that means is that we could draw a line, and that's what the figure is reflected over. So the first thing we're going to figure out is that line of reflection. I don't know why I'm hitting myself today. Okay, so our examples use a lot of words, but I swear they're really easy. The first example tells you about quadrilateral JKLM, and it tells you all its vertices, but how very nice of them. They've already plotted it for us. You okay? Okay. They've already plotted it for us. Okay, so the first sentence we don't really need. The next sentence says the graph JKLM and its image over x equals 1. So that is going to be our line of reflection. So I'm going to go ahead and color my line of reflection. It's x equals 1. So it's going to be this line right here. Oh, wait, they already drew it for me. I'm not paying any attention. Miss Compton. Get it together. I hope you drew in pencil. Good thing I have ink lots of copies for myself. Okay, so the regular coordinate plane was here. So that line of reflection, x equals 1, is actually drawn for us. Now, that was really nice of them to draw it for us, and I've colored it in yellow. They do not have to draw it for us, just like they don't have to plot those points for us. They kind of expect us to use our brains to figure that stuff out ourselves. Okay, so if something's reflected, you see a mirror image. So we've got to figure out the mirror image of each point on this shape. For instance, you see how M is one block to the left of that yellow line? Then our new M is going to be one block to the right. And anytime it's a new position, we call it like M prime, meaning I just put a little dash after it. So there's M prime. Again, so here's my yellow line. Originally, M was one to the left, so my new M is one to the right. Okay, so I go to J. J is one to the right, so my new J is going to be one to the left. There's J prime. I go down to L. L was one to the right, so my new L is one to the left. And I can't forget about K, because let's see, I've done J, L, and M. Yeah, I gotta do K. K was 1, 2 to the right, so I need to go 1, 2 to the left. It was 1, 2 to the right, so I need to go 1, 2 to the left. Okay, and of course I need to connect the dots. So J and K, K and L. And now we kind of see it. It looks like this shape was flipped that way. It was flipped over that yellow line. Is there anyone who doesn't understand how I was counting? Okay, again, the reason I'm counting, since my yellow line was up and down, that's why I just paid attention to 1 to the right, 1 to the left. one to the right, so now I go one to the left. It's not always going to work this nicely. Are there any questions about that one? Okay, well the next one actually requires us to do a little work, so go ahead and plot those 4 coordinate points. It says, so here's your axes. It says J is at 2, 3, so 2, 3. And there's J. K is at 3, 2, so 1, 2, 3, 1, 2. There's K. L is at 2, negative 1, so there's L. M is at 0, 1, so there's M. And I connect the dots. It stinks that they chose those vertices because now it's super duper tiny and I can't zoom in any further. Does anyone have any issues plotting those 4 points? Okay, well then if we keep reading, it says to take this shape and graph its image over y equals negative 2. So that is going to be our line of reflection. Okay, now in x, last time we did x equals 1 and it was a line that was up and down, like a column. Y equals negative 2 is going to be a line like this. So I need to go to negative 2 on the y-axis and draw my line of reflection straight across. So that is my, I'm going to call it LOR, line of reflection, y equals negative 2. Okay, so on the last example, I used yellow. So I would count from the yellow and see how many spots to left or right our dots were. This time I'm going to count up or down. So since L, for instance, is 1 dot above, L now needs to be 1 dot below. So my L prime, L was 1 dot above, L prime needs to be right here, 1 dot below. It's really hard to say that. M was, here's my pink line, M is 1, 2, 3 above, so my new M needs to be 1, 2, 3 below. 1, 2, 3 below. J is 1, 2, 3, 4, 5 above, so my new J prime needs to be 5 below. So 1, 2, 3, 4, 5 below. And then K is 1, 2, 3, 4 above. So K prime needs to be 1, 2, 3, 4 below. And of course we need to connect the dots again. Now on the test on Friday, 1, the shapes are bigger than this. I swear they're not this tiny. I swear they're not. And 2, a lot of the questions are, to my advantage and your advantage, an easy grade for me and a nice grade for you, multiple choice. So a lot of the questions are going to be, can Harrison spot the right reflection? Now, are there a couple where Harrison has to draw his own? Yes. But most are going to be, can Harrison spot the correct reflection? But you can see how that could get really confusing. Because if I just move M prime over here, I just mess up 1 point. Harrison doesn't catch it, suddenly he misses the whole thing. So there's a little bit of a catch-22 with that. Is everyone good? Everyone nice and bored on this so far? Good. Okay, so now we get to our next example, and it says, they've already graphed it. I don't know why they give you the vertices if they've already graphed it. Graph quadrilateral, ABCD. They tell you the vertices. And its image reflected in the x-axis. Okay, now we've actually got to use our brain. It didn't tell us a specific line, so that line of reflection is actually in the x-axis. So did we really use our brain? Not so much. That's our line of reflection, is the x-axis. Now I like my counting strategy. So A was 1 up, so A prime's 1 below. B was 1, 2 up, so B prime's 1, 2 below. C was 1 below, so C prime's 1 up. I like this counting strategy. 1, 2, 3 down, so 1, 2, 3 above. Is there anyone who doesn't understand how Miss Compton's counting this stuff? How she's moving one point to a new point? Okay. Well, if you want to be fancy, my counting strategy works. Keep that in mind. If you want to be fancy, anytime it's over the x-axis, anytime that is our specific line of reflection, it said specifically it was the x-axis, all you actually have to do is multiply the y-coordinate by -1. So, for instance, A was 1, 1. A prime is 1, -1. But, hey, 1, -1, that's what we graphed already anyway. B prime would be 3, -2. But we already did 3, -2. C prime would be 4. Negative times a negative makes that a +1. But we already put it at 4, 1 anyway. And then D would be 2, +3. Miss Compton already did 2, +3. So does Harrison have to remember that trick if he's got my counting method down? No. Is it useful just in case? Of course. Are there any questions on that one? I swear I've got 2 left and then it's all you. Okay, well, if you read the next one, again, they've gone ahead and graphed it for us. How nice of them. Well, I guess we didn't need practice graphing today. They said we're going to reflect over the y-axis. So the y-axis is our line of reflection this time. Similar to the x one, when the x was the line of reflection, you could technically multiply all the y-coordinates by -1. For this one, you can technically multiply all the x-coordinates by -1. So I already know A prime is -1, 1. B prime is -3, 2. C prime is -4, -1. And D prime is -2, -3. But while that's great, and that trick's always going to work, again, if Harrison understands how I'm counting this, he was going to count the right places anyway. Because he knew A was 1 to the right. He was going to put A prime here anyway. And look, that would be -1, 1. That's what I said it was going to be. So if Harrison understands his counting, does he have to remember this trick? No. I was already going to put A prime here. 1, 2, 3. 1, 2, 3. I was already going to put B prime here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Did I count that right? 1, 2, 1, 2, 3, 4. It should just be 4, not C prime. And then 2, 2. Okay, so let's talk about how Harrison could possibly mess this up. Because I like to pick on Harrison. If suddenly his shape turns into a triangle, if his shape suddenly changes into a perfect square, if his shape changes shapes, then we have an issue. Just because it's reflected doesn't mean it's still not like A and B are short, C and D are a little bit longer. That's still staying the same. So I catch Harrison quickly if he messes this up. Harrison can't count, he messes this up. Harrison's a good counter, he's got that much. I don't think there's any way Harrison's going to miss the top 4. The only one he could potentially miss is the very bottom example that we're going to do. It's the only one that requires a little more thought today. What does it say the line of reflection is in example 5? Y equals X. Okay, so we have an issue. Because this is our line of reflection. And we don't know how to plot that. Do we? What does Y equals X look like? You had algebra class. You passed. You got to me. What does Y equals X look like? Anybody? Well, it needs to be a line because we're talking about a line of reflection. Why would this one be hard? I'm going to make you talk. Let's see. What do I have to offer? For a pack of gum, why would this one be hard?
It's just a straight line.
Where do I put the line? Show me with your arm, and I'll give you the pack of gum. Hey, it's not a line like this. It's not a line like this. Anna's right. It's a tilted line. So we finally made it an issue. I know, man. Why didn't you answer the question? You knew Y equals X. Okay, so it's the tilted line. It goes through the origin. I did not do a very good job highlighting that. It goes through the origin. It goes through 1, 1, 2, 2, 3, 3, 4, 4. So what makes this one hard is that it's a straight line. Thank you, Ayana, for helping me with my tilted line. Struggle was real this morning. Harrison, do you like counting? Not really? Okay, Harrison, I'll give you some options. You can either fancy count, or I can show you a different way. Which one do you want to do? Okay. If it says Y equals X, you need to, it says interchange, meaning swap. So swap X and Y's. Okay, if you swapped X's and Y's, for instance, B would become 2, 3. What would A become? What would C prime become? You already got your pack of gum, chill out. What would D prime become? Okay. So that's one way Harrison can do it. Now he knows all the points to plot. Harrison, you can tune me out from here on out if you're going to remember that. Go plot those points, connect the dots. You got this. However, that's not my way. That's nice. I'm glad Harrison can do that. I'm a counter. I like counting things. So, when I say it requires a bit of a fancy count, that's because I can't just count, oh, that's 1 to the right. I have to count how many over and up I'm going. So, Harrison might want to do this way. For instance, to get from B to that pink dot, I would technically go trying to think of how to explain this. Well, best way I know how. If we were to reflect it, A would stay the same because it's already on the pink line. B's got to go a little to this side, so it's going to go here. I'm not even going to count. B prime will go there. C prime needs to go somewhere over here. Since C prime is, I don't know, 1, 2, 3, 4 over, 1 down, it needs to go 2, 3, 4 over. -1, 1, 2, 3, 4. Somewhere over here. And D prime, I know it's going to go over here somewhere. Okay. D prime. So what really happened, Miss Compton was guessing. So I knew it looked kind of like a kite. We'll pretend it is a kite. It looked like a kite. I knew the kite somehow had to swing over the pink line and A not move. So I knew it was going to look about like this. Is guessing a good idea in math class? Probably not. It's probably a good idea to remember we're just going to swap the X and Y coordinates. If we looked at those coordinates that Harrison decided we should list, we did 1, 1, hey, that's where I put A prime. We said B was 2, 3, hey, that's where I put B prime. We said C was -1, 4, that's where I put C prime. D was -3, 2, should be here, so D prime's here. Dang, Miss Compton made a mistake today. Oh, I love making mistakes. Am I going to catch A on it if she's off a teeny tiny bit? Probably not. But if this is a multiple choice test, is Ayana going to catch it? Because all the answer choices all look real nice. Okay, does anyone have any questions before I stop rambling? Okay, then I'm going to hand you yours. There are quite a few of these, and if I were you, I'd try to get as many of them done as I could. The first couple are easy. We'll look at them together. Hold on. 4, 5. Okay, so let's look at it real fast. The first 4 are as easy as they look. They've drawn the line for you. They drew a diamond here, so just draw a diamond below the line. That's all you have to do. Now, I need Harrison to realize that since A is on top, A prime is going to be on the bottom. But seriously, as long as he has a diamond somewhere below down here, I'm not going to be like, Harrison, that's the ugliest looking diamond I've ever seen. I'm not going to say that to Harrison. Mine's not very pretty. So the first 4 are as easy as they look. Reflect the shape over the line given. 5 through 8 actually require a little bit of effort because you have to plot the points yourself first and then do the reflection. I'm really only going to notice if Catherine has reflected a triangle, for instance, like on number 5, and it suddenly becomes a square. That's going to be an obvious notice. On the back, it tells you where to reflect the line. It's already drawn it for you, so in my mind, the back's actually a little easier than the front. Number 3 says it's a bonus, but it really shouldn't be a bonus. It's still a diagonal line. It's just going to be a diagonal line tilted this way. You can figure out the X and Y coordinates. You're pretty smart. Okay, the only one that makes me worried you're going to miss it is number 6, and that looks like our last example. Are there any questions about this worksheet? I do not want it in my hands tomorrow, but when I tell you the test is on Friday, you understand that means you need to get it done as quickly as you can.